Bismillahir Rahmanir Rahim. In this lecture, we have to discuss a counter example. F of x is equal to x absolute. This particular example, here the function is continuous everywhere but not differentiable at a particular point x is equal to 0. We can easily observe the absolute value graph is continuous as we can draw the graph without faking of your fence. Here are two branches. One is line x equal to f of x is equal to minus x, and another branch is f of x is equal to x. So this means that the graph of x absolute is the combination of two lines minus x and x. Now, but now but we can also quickly see that the slope of the curve is different on the left as it's on the right. This suggests that the instantaneous rate of change is different at the vertex point x is equal to 0. We use one-sided limits in our definition of derivative to determine whether or not the slope on the left and right side are equal. So first we have to check from negative sides. Limit h tends to 0 through negative side. F of x plus h minus f of x divided by h is equal to limit h tends to 0 through negative side. But the given function from the negative sides is equal to minus n to x plus h minus n to minus x divided by h. Now this limit becomes limit h tends to 0 through negative side minus x minus h plus x divided by h. Now minus x and x cancel with each other. So this limit becomes limit h tends to 0 through negative side minus h divided by h. Now h cancel with h. So this become minus 1. So limit h tends to 0 through negative side of minus 1 is equal to minus 1. Now limit from right side. Here the function is f of x is equal to x absolute. So from right side f of x plus h is equal to x plus h and f of x is equal to x. So limit h tends to 0 through positive side of f of x plus h minus f of x divided by h becomes limit n tends to 0 through positive side f of x plus h becomes x plus h, and f of x becomes x divided by h. Now the whole limit become limit h tends to 0 through positive side, h cancel with h. This become limit h tends to 0 through positive side of 1. This is equal to 1. So right hand limit is equal to 1 and left hand limit left hand limit is equal to minus 1. So on upon comparison, we find that the slope of the left side is equal to minus 1 and the slope of the right side is equal to plus 1. So they disagree. This means that limit does not exist here at a point x equal to 0. Therefore, the function f of x is equal to x absolute is not differentiable at x equal to 0. While the function is continuous, it is not differentiable because the derivative is not continuous everywhere. So the graph of x absolute is like this, but the graph of derivable function f dash of x equal to 1 when x greater than equal to 0 and f of x is equal to minus 1 when x less than 0. The graph of this function is like this. This means that the graph of the given function is continuous, but the graph of the derivable function is not continuous. Thank you so much for watching this video. Please subscribe the channel for more informative videos on calculus and analysis.